Hi. So today we're going to talk about density. All right. I'm going to try to keep this as simple and as quick and as possible and as painless for you as possible. So density is basically, we did the simulation in class, we looked at it, but now we got to do some calculations that go along with it as well. All right. The density formula, I assume some of you have probably seen this before, some of you maybe not. So the density formula is pretty simple. All right. It's just density, generally represented by a D, uh, is equal to mass over volume. Some people, trying to remember this, they like to write it out. They say the density heart, where you do like the M, then you do like the little V, and it makes like a heart. And you're like, oh, look, it's a heart. And isn't that lovely? And I'm just like, no, that's not my thing. I'm not a big fan of drawing hearts, as you can imagine. But I mean, if it helps you remember, I mean, really, that actually does help a lot of people remember. I make a much bigger joke about it in class if we were like in class, and I'm not doing this on YouTube. But whatever, you get the idea. So the density formula is just density is equal to mass over volume. All right, the mass of an object, mass is m. We'll write it out. That's m. This is generally in grams. Sometimes it could be in kilograms. It's usually in grams though. The volume volume is, it's the space something takes up. That's V. This is generally going to be in milliliters or liters, usually milliliters. Or every once in a while, you might see it written in cubic centimeters, which if you remember from class, cubic centimeters is the same thing as milliliters. So remember, 1 milliliter is equal to 1 cubic centimeter. That will matter. There's a problem on your homework like that. So we have this looking very nice, except for these crossed out density hearts, which, that's okay. Now, I want to just do a couple like really simple example problems for you, and then I'll do like one example from your homework, and that's it, and then I'll let you get to work. I mean, for the most part, this is pretty straightforward. There's nothing too crazy about it. So let's say we've got a I'm really simple to start with. So if you want to move along to the example problems, you can go ahead a little bit here. But like super simple example problem. Let's say that we are told that we have an object that has a mass, so its m is 30 grams. All right, and it has a volume of 15 milliliters. The problem simply says then, what is the density? Like, what's the D? What's the density? Let's make that. All right. So to figure this out, all you'll do, let's turn the light on. All you'll do here, you're just going to plug in your numbers. I mean, the math portion of this, it's pretty straightforward. It's just plugging in numbers into the formula. That's why we did the whole simulation thing also to understand like the idea of density and how that works and everything. So, all right, let's say we've got this. So our density, our mass is 30 grams. So we're just going to do mass over volume equal to density. So we've got 30 grams. We're going to put it over 15 milliliters. And I mean, yeah, it's just 30 divided by 15. That will give you your density. And in this case, your density will be equal to 2, number 2. But the thing is, we're not done yet. That is not the correct answer yet. The reason it's not the correct answer, units. Units always matter in these problems. Like we've been talking about with the scientific or with the dimensional analysis stuff, units matter. So in this case, they don't cancel out. Grams and milliliters, like you can't cross off grams and then cross off milliliters. It doesn't work. So instead, you're just going to write grams per milliliter. That's the density. It's grams per milliliter. So the density unit, going back up to here now, the unit for density, all right, it'll always be one thing over another. It will always be a mass unit, grams, over a volume unit, generally one of these three that you see here, whether it's liters, milliliters, or cubic centimeters. So density, the units are going to generally be grams per milliliter. That's going to be like number 1 most common, or any combination of a mass over volume. So that's the correct answer now. All right, so next, we'll do an example from your first, let's actually talk about the algebra behind doing a slightly less straightforward problem, I suppose, because that's a question that everybody always has. So let's say you are told that you have, instead, you're told what the density of something. You said, okay, so example 2. So let's say that you have a density of 3 grams per milliliter. Cool. And that you have a volume, that this thing takes up a volume, takes up space of 10 milliliters. All right. The problem says, what's the mass? So how are we going to find the mass of this, or how are we going to find the mass of this thing if we know the density and the volume? Well, remember, our formula is density is equal to mass over volume. Now in this case, we know V and we know D. So what I suggest you do, and I really mean, there's only 3 possible ways that this formula can be written. So that's nice. There's much harder stuff that we could be dealing with in terms of algebra. This is pretty simple. And I know a lot of you, I bet everybody watching right now can follow along to like plugging units in, but then some of you do get stuck on the algebra. And that's understandable because like some people in math, math is not your best friend. You don't go like on like long walks with math and be like, yeah, math, you're my best friend. This is amazing. Like we should get friendship bracelets and hang out and like I don't know if you still do friendship bracelets. It's like we should get a Snapchat streak going, math, and just like never miss a day. That's like the new thing, right? Maybe you guys don't do that anymore. I hope not. Whatever. But the point is, you might not like math. Hopefully you do. But if you don't, okay. Let's deal with that. So the way you're going to do this, you are going to, and for those of you that are just like rolling your eyes and being like, oh, math's so easy, you're lucky. Consider yourself lucky because a lot of people, it's not that easy. So be happy about that. Anyway, so you are going to basically, I suggest rearranging this equation before any numbers are plugged in. I know some of you don't like that, but this is the best way to do it. It's the simplest way to do it. So algebraically, we are trying to solve for m. That means we want to get m by itself on one side of the equal sign. So pretty much we just need to get v out of here. We need to move v to the other side. So to do that, I'm just going to multiply both sides of my equation by v. So I'm going to write a little parenthesis there. And really, if you're like multiplying by v over 1, I'm just going to write v. So what that does for you then, this v, it goes away. It gets canceled out. And your formula now is volume times density is equal to mass. If you prefer, I can write it with little parentheses to indicate the multiplication, even though you don't need to with variables, but some people like it better that way. I even like it better that way. And then now you're just going to plug your stuff back in again. So volume is 10 milliliters. Our density in this case is 3 grams per milliliter. And you'll multiply them together. Now in this case, the units do cancel out. So you're going to cross off milliliters, and you'll be left with just 30 grams. Not 30 grams per milliliter. The milliliters are gone. The reason they're gone, it's you have one on top, one on the bottom. They cancel out. They're gone. So in this case, your mass is 30 grams. All right, and then example 3 will be, how do we solve for volume? Just again, because some of you, I know, you need that. You want to know how to do that. All right, again, if you're good with the algebra, go move on. So example 3 here. Let's say that in this case we have another object. We know the density is, in this case, let's make the density 4 grams per milliliter just to be different. And we know that we have a mass of 20 grams this time, a mass of 20 grams. I'm trying to keep the numbers nice and simple for you. And we are like, we are asked, what's the volume? That's a question mark, not a 2. Looks like a 2. But so we are asked, what is the volume? So again, you got your formula. Density is equal to mass over volume. Now, simple way to look at this is actually to take the formula that we have up here. It's a good formula, and I'll probably confuse you guys, but you can just manipulate this equation, and you look at it pretty quick, and some of you are probably just like, oh, if I'm going to find mass or a volume, I just want to put density on the bottom. I just want to take density, move it over here, which is fine. But I'll write it all out right here. So we again want to get v by itself, not on the bottom of an equation, but on top, so that there's no issues. So pretty much what we'll do, we're just going to do the same thing we did last time, where we're going to take and multiply both sides by v. So we'll multiply both sides by v. And you end up with volume times density is equal to mass. Okay, cool. But now there's one more step you've got to do. You now have to convert and get volume by itself. So how do you do that? You want to move D now to the other side. So you're going to divide both sides by D. Goes away, and your formula now is V is equal to mass over density. Simpler way to do it, because I know some of you don't want to bother with that, and that's understandable. A simpler way to do it, though, I think it's good you understand the algebra, but a simpler way to do it is simply look at density is equal to mass over volume. You can just trade the places of these two things. So if you have an algebraic expression like this where you're trying to solve for the unknown that's on the bottom of a fraction like this, or it's on the bottom of the division problem, just switch it with the other side of the equal sign. And that'll work algebraically. It's the same thing. So anyway, now that you know this, you're just going to take your mass, you're going to plug it in down here, that's 20 grams. That's from here. You're going to plug in your density, that's 4 grams per milliliter. And you will just go through and that'll be equal to volume. So in this case, you'll do all the math and you'll just say, 20 divided by 4, what is that, 5? So that's 5. Now, the grams cancel out, and you're actually left with 1 over milliliter, which, don't worry about that. It's just going to be, milliliters is the only unit left. Just for the sake of simplicity, if you end up with 1 unit left over, just trust me, it's going to be written like it normally would be. So it's just 5 milliliters. So that's another example. All right, now let's talk about just like 1 or 2 of these from your homework. There's only 8 problems, so I'm not really going to do too many of them for you. But I do want to actually, I think you probably can do the homework. But I want to give you one other really quick example, then I'll stop. So let's say we have one last example. This one's a little more complicated. Let's say we have a completely randomly shaped object. I don't know what that is. That's an object. All right, it's randomly shaped. Not super easy to measure the volume of that. If it was in 3 dimensions, it'd be even goofier. So we don't know what the volume is of it. No idea. All right, and there's no simple way to measure. If you have a box, I'm going to draw a perfect box, obviously here. Oh, it was good until then. All right. So let's say we had a box. You just do volume is equal to length times width times height, right? Simple. X is for multiplication. I haven't done that in years. But you just multiply the length times the width times the height. Pretty simple. You get if you have like a nice right angular cube type thing where you have all 3 right angles. That's nice. That's great. But you're not always going to have that. So let's say we have a problem like this. All right, where we're told this. We're told this has a mass of 7 grams, whatever. That has a mass of 7 grams. All right, but we don't know what the volume is immediately. So let's say, how do we find the volume of random object? Well, what we'll do, it's called water displacement. So if you wanted to find the volume, the space something takes up, and again, you saw this in the simulation, but let's say we want to do that, and what we'll do, we'll have a graduated cylinder. All right, so a graduated cylinder, remember, assume it would be big enough to hold this. This measures volume, so you can measure the volume. So you can measure the volume of this. Now, the way you would measure the volume, you would find an initial, so we would have, some water level right there. You just use water. You'd have some water level enough to cover the object. All right, ideally, I'm not drawing this to scale perfectly because I'm not a very good drawer, as you can tell. But you want to have enough water to where it covers the object. And let's say, so our initial volume, if you don't know what the word initial is, it means first. Initial volume, our initial volume, it will say is 20 milliliters. All right, that's your initial volume. All right, so then you have, so this is before, now let's draw an after. Same graduated cylinder. We now have, it's higher, and you now have your, that's supposed to be the same object. I don't know. You now have your object in there. But now, so this was the initial volume was 20. And now we put it in there though, and now the final volume, after we put the object in there and it's completely covered in water, the final volume is now equal to, we'll say, 30 milliliters. Keep it really simple with the numbers. So this, you're going to see this on the problems that you're going to do. It's not drawn like this, it's described. But basically, how do we know the volume of this object? Well, to find it, you know it now, you just got to calculate it and figure it out. To find it, you put this object into the water rises a certain level. All right, as the water rises, and it completely covers the object, you then get the final volume. That difference, when you subtract 30, you do 30 minus 20, that difference, when you take the final volume, 30 milliliters, minus the initial volume of 20 milliliters, and you obviously have a 10, then you obviously have a 10 milliliter, difference. That is equal to the volume of the object. That is how you figure out the volume of a weird looking amorphous non-right angled object. Water displacement. Because the water covers everything, and that difference in the volume, or that difference in the volume of the cylinder, that's the volume of the thing that you put in. That's why when you get in the bathtub, the water goes up. That's how it works. You displace stuff in water, and water then it covers every nook and cranny and everything. You can't do this with hollow objects though. So if an object is hollow, water, but it's sealed, that will mess with the density and doesn't work. So water displacement does not work with hollow objects or anything that has enclosed spaces. It only works with it would work with this pen. It would work with these sunglasses if you could get them to be, sink in water, but they're less dense and probably would float. Why do I have sunglasses? Because I've been wearing sunglasses in this room because my eyes are hurting from looking at the computer so much. So I've been sitting there at a screen just looking like this for like hours. It's weird, but I get less of a headache from it. So there's that. Anyway, so now the rest is pretty easy. You know the mass now. You know the volume. So you're just going to do mass over volume is equal to density. So let's move this out so you can see the whole paper. So again, our mass is 7 grams. Volume is 10 milliliters. So we'll just do 7 grams over 10 milliliters. And that is equal to density. So just do this. It's just so your density is going to be equal to 0.7 grams. Sorry, 0.7 grams per milliliter. And that's it. I'd ask if there were questions, but you're all watching this, and you're not here to ask. So now your density practice homework, it's pretty straightforward. You're just going to be looking at this. So in terms of doing this, there's an example problem on top. What I would suggest you do, I would really suggest that you go through and for a problem, like these problems have words, and I didn't show you examples with words, but it's the same stuff. Just go through and identify, so 5 milliliter sample of water. What's a milliliter? That's a volume. That's obviously your volume. This says it's a mass, so that's your mass. All right. You just identify what's what. Like grams is mass, right? It says the density of this is whatever. So there's the density. It identifies it for you. All right. So make sure you're paying attention to that as you read it. So you should be able to do this. The first three are really simple. The fourth one's a little in, and then the 5 through 8, they start presenting you with other scenarios. It's exactly the same stuff, just like what you got to do, like the water displacement thing, where it gives you an initial and a final volume or something like that. So good luck. Hope that was helpful.